In this video, we're going to look at how we can take that last equation that we solved by Gaussian elimination and take that and using matrices, hopefully make that a little more streamlined process, a little more organized, and a little easier to follow what's going on. So we want to look at two special matrices. And the first one is the matrix formed by just taking the coefficients of the original equation. So if we look at just this part of the original equation and just leave the x's, y's, and z's out, then we get this matrix. Matrix 1, negative 2, 1, 2, negative 3, 1, and 1, negative 2, 2. Recall that in a matrix, the first position here is the 1, 1 position because that's the first row and first column. And then the second one would be the 1, 2 position and the 1, 3 position, and so on through. For the second row and first column, we have 2, 1. So we can refer to the positions that way. So there's the coefficient matrix. Now, for our purposes right now, we're really more interested in a slightly different matrix. And that is if we take and look at the whole thing and just using the numbers and dropping everything else out of it. We call that the augmented matrix. And so here we have the augmented matrix. It's the same as what we had before, but we've taken and added another column with what was on the right side of the equal sign. So we see the 3, 3, and 5 going down on the right side of the equal sign there. And here we have the 3, 3, and 5 added in there. So we just want to kind of get used to the idea of these matrices for a little bit here, and then we're going to see how we use those. So we just want to write the augmented matrix for this system of equations. We notice that there's a little bit of a problem in that the x's, y's, and z's, and they threw a w in there, they don't quite line up. And so we want to put some zeros in the appropriate places there in writing the augmented matrix for this. So using alphabetical order, going w, x, y, z. So for the first equation, we don't have any w, so we would put a 0 for that. A 1 for the x, the coefficient of the x, the coefficient of the y, the coefficient of the z, we need a negative 1 there. And then what's on the right side of the equal sign, so 5. In the next one, we have a 2 with the w. So our first column is our w's, then our x's, y's, z's, and the solution column. So we have 2, 3, there's no y, so we're putting a 0 there, a negative 1 again for the z, and a negative 2 in the solution column. Got to be very careful in writing these to keep them nice and neat and everything lined up properly. And in the last one, we have a 2 for the w again, a negative 1 for the x, a 1 for the y, 0, z, and a 6 for the solution. So there's the augmented matrix. That's all we're looking for that one. So take a minute and write the augmented matrix for this next system of equations. So again, once again, we have w, x, y, and z. And here we have the augmented matrix for that system of equations. Note that this is a 3 by 5 matrix. I'm sorry, that's not a 3 by 5 matrix. That is a 4 by 5 matrix, 4 rows and 5 columns. So that's going to be important to us later on, the dimensions of that matrix.